In the early 2000s, retired machinists around Worcester, Massachusetts began receiving letters from the United States Department of Labor. The government was offering them $150,000 each, plus lifetime medical coverage, if they could prove one thing: that they had been inside a certain factory on New Bond Street during a single week in May of 1960. The factory had been shuttered for years by then. The company that ran it had been dead since 1992. And most of the men who qualified for the money had no idea what they had ever done to earn it, because the answer had been sitting in classified federal files for 4 decades. This is the story of the Heald Machine Company, and it begins a very long way from the atomic age. This is Trade Archive. If forgotten industrial empires are your thing, hit like and subscribe. You don't want to miss this one. Barre, Massachusetts, 1826. Stephen Heald sets up a blacksmith shop on a stream in the hill country of Worcester County, a good day's ride northwest of the city of Worcester. Over the years, it grows into a small water-powered foundry and machine shop, and the little settlement that forms around it eventually picks up a name of its own. People just call it Heald Village. The customers are the farmers and loggers of central Massachusetts, so the products are whatever farmers and loggers need. Cast iron sled shoes and water wheels, sawmill machinery and fire pumps, and increasingly clever woodworking equipment, including a foot pedal miter trimmer the company sold as the American Sash Trimmer, a heavy floor stand machine that promised carpenters it would cut the punishing labor of hand-fitting window sash joints by as much as 75%. For a rural shop in the 1800s, that was aggressive marketing. It was also true, which is why it sold. One detail from those early decades tells you exactly what kind of operation this was. Through the 1850s, the Heald Foundry was the only one within a 25-mile radius. The railroads hadn't reached that corner of the county yet, so every ton of pig iron and every load of coal arrived the hard way, teamed over rough roads by horse and wagon from the nearest railhead, 25 miles out. Picture running a foundry, an operation that eats coal and iron for breakfast, when your raw materials arrive at the speed of a walking horse. The Healds did it for decades, and they did it profitably, because for a quarter of the county, there was simply nowhere else to get iron cast. As New England industrialized around them, the shop adapted with it. The product line drifted from purely agricultural work toward machinery for the region's booming wire drawing mills, a first tentative step out of wood and into precision metal. Everything was still cast in the family's own water-powered foundry, machined on the family's own equipment, and finished by hands that had learned the trade from the generation before. Vertical integration wasn't a strategy for the Healds. It was simply the only option available at the end of a wagon road. Around 1860, Stephen brought 2 of his sons into the business, and the sign over the door changed to S. Heald & Sons. When Stephen passed, his son Leander carried on with his own son James, trading as L.S. Heald & Son. 3 generations, 1 shop, and so far a story you could tell about 100 New England family businesses. James is where it stops being ordinary. James N. Heald was something the first 2 generations were not: a formally trained engineer. He graduated from Worcester Polytechnic Institute in the class of 1884, then came home to the family shop and started steering it away from farm tools and toward precision metalworking. He developed a lathe attachment that could perform both internal and external grinding, a hint of the obsession to come. Then he built the product that blew the roof off the company's ceiling: the American Twist Drill Grinder, one of the first purpose-built machines anywhere for sharpening twist drills. Machine shops on every continent needed sharp drills, and the American Twist Drill Grinder sold worldwide in large numbers. Suddenly, a village shop at the end of a wagon road had an international product line. And that was exactly the problem. You cannot run a global machine tool business from a place the railroad never reached. Every machine shipped out faced the same 25-mile haul the pig iron faced coming in. So, in 1903, James arranged the financing, bought out his father's interest, and moved the entire operation to the city, incorporating the Heald Machine Company on August 26, 1903. The decision seemed obvious in hindsight. At the time, it meant walking away from 77 years of roots, a village that carried the family name, and betting everything on one product category in a crowded industrial city. The new plant went up at 10 New Bond Street in Worcester's Greendale neighborhood, more than 28,000 square feet of factory with a railroad spur built right to the door, so freight cars could be loaded on site and shipped anywhere in the country. Worcester at the turn of the century was one of the most aggressive machine-building cities in America, thick with skilled tool makers and wire mills. And right next door to the new Heald plant sat the Norton Company, on its way to becoming the largest abrasives and grinding wheel maker on Earth. If you are going to bet your family's future on grinding machines, next door to the world's grinding wheel supply is the neighborhood to do it in. The bet paid off almost immediately, and in a way nobody could have scripted. In 1905, Heald introduced a rotary surface grinder for finishing the sides of piston rings. Piston rings meant engines, and engines meant the loudest, fastest-growing new industry in the world, the automobile, which is how James Heald came face-to-face with the problem that would define his life and, honestly, the next century of manufacturing. Early carmakers were struggling badly to finish engine cylinders. The standard methods were boring, reaming, and lapping, and the results were rough because a cylinder wall is thin, and thin walls flex. Push a cutting tool against one, and the metal springs away from the edge, then relaxes behind it, leaving a surface that is subtly, fatally uneven. Grinding could fix that, since a grinding wheel cuts with far less pressure. But grinding a hole the conventional way means spinning the workpiece around the hole's own center line, and nobody on Earth could spin a heavy, lopsided engine block with 2, 3, or 4 cylinders cast into one lump of iron around a single cylinder at a time. The geometry simply refused to cooperate. So Heald flipped the geometry on its head. In 1905, he devised an internal grinding machine in which the engine block never moves at all. It sits clamped and stationary while the grinding wheel spins at high speed, and the entire spindle travels in a perfect planetary orbit inside the bore, like a moon tracing circles inside a tube. The wheel does all the work. The workpiece does nothing. He patented the machine with a Worcester engineer named Ralph L. Morgan, United States patent number 810,426, granted in January of 1906. The advantage was decisive, precisely where carmakers hurt the most, on cylinders cast in pairs or in blocks of 3 and 4, castings that could never have been swung around a single bore. On a Heald planetary grinder, it made no difference how heavy or how lopsided the casting was, because the casting never moved. And the design was so fundamentally correct that planetary internal grinders, built a full century later, differ from it surprisingly little. Almost overnight, this became the standard method by which the entire world machined engine cylinders. It's worth pausing on how this company built its own machines, because the answer explains everything that comes later. A trade writer who toured the Worcester plant around 1909 described an inspection system that was, for the era, borderline obsessive. Every individual component was tracked from the moment work began on it, through every single machining operation, until it was finished and cleared for assembly. Then the completed machine was run in and tested all over again on top of that. Nothing left the building on trust. Heald's stated personal obsession was to make every grinder that went out the door a little better than the one before it. Keep that culture in mind, precision as a kind of family religion, because in 1917 the United States went to war, and that religion suddenly became a national resource. America's great mechanical contribution to the First World War was the Liberty engine, a 400-horsepower V-12 aircraft engine with cylinders 5 inches across, and Detroit built it at a scale nobody had ever attempted with an aircraft power plant. Ford, Lincoln, Packard, Marmon, and Buick together produced 20,748 Liberty engines before the armistice, an almost absurd number for 1918. Every one of those engines carried 12 cylinders, and every cylinder had to be finished to aviation tolerances. Where a flawed bore didn't mean a breakdown on the roadside, it meant a dead pilot over France. The machines that could hold those tolerances inside an engine bore were internal grinders, the precise technology Heald had spent a decade making its own. Aircraft engine output was, in a very real sense, capped by grinding capacity, and grinding capacity meant Heald. In the space of 15 years, the grandson of a village blacksmith had become a strategic military asset, and the machines coming out of New Bond Street were treated accordingly, priority freight for a war being fought an ocean away. And when the war ended, Heald didn't coast on it. The 20s and 30s at New Bond Street turned into the kind of innovation streak most companies never get once, let alone sustain for 2 decades. First came hydraulic table feeds and automatic size control, sold under names like Size-Matic and Gauge-Matic. These systems let an internal grinder measure the bore while it was still grinding and stop itself at final size, holding tolerances of 1/10,000th of an inch with minimal operator supervision. To translate that number into human terms, a sheet of printer paper is roughly 30 times thicker than the total error those machines were permitted. A worker no longer had to be a 20-year master to produce master-level bores. The machine carried the skill, and factory throughput exploded accordingly. Then, in 1932, Heald registered a trademark that would become famous on shop floors and, decades later, in a federal courtroom. Borematic. The Borematic line was a family of ultra-precision boring machines built around modular, interchangeable bridge and table units, and the double-end versions were genuine mechanical theater. The table traversed left so the spindles could bore and plunge face one end of a part, then swept back to the right to machine the opposite end, all in one continuous automatic cycle, all holding aircraft-grade tolerances. In 1933, the company added a new internal centerless grinder that eliminated the chucking problems that had plagued earlier designs, letting hardened rings and races be ground without being distorted by the very jaws holding them. And running through all of it was the product that became Heald's visual signature, the high-speed grinding spindles the trade simply called red heads. You could spot them from across any factory floor by their bright red housings. They were permanently lubricated, dynamically balanced, and engineered for brutal continuous duty, delivering full power to the wheel at speeds that started around 7,500 revolutions per minute, and, on specialized small-bore units running oil mist lubrication, climbed past 100,000, a spindle spinning 100,000 times per minute, all day, every day for years, while holding a wheel steady enough to grind to a 10,000th. Building one meant grinding the spindle's own bearing journals to tolerances tighter than anything the spindle itself would ever produce, which is a wonderfully circular problem, precision machines being used to build the precision machines. All of this machinery fed one customer above every other: Detroit. The American automobile boom of the 20s was, at the machining level, a bore finishing boom. Millions of engine cylinders, wrist pins, and bearing surfaces per year, every one of them ground or bored on somebody's equipment, and an enormous share of that somebody was Heald. When Ford or Chevrolet redesigned an engine, planners in Worcester were among the first to know, because a new engine meant a new generation of grinders and borematics tooled to match. The company at the end of a wagon road had become invisible infrastructure for the entire motoring world. For a while through the 30s, life at Heald looked like a straightforward, prosperous march. Good products, a fortress location, patents stacking up. That calm version of events did not survive the decade. When the Second World War came, the tolerances Heald lived by stopped being a commercial advantage and became a matter of life and death at industrial scale. High-performance aircraft engines simply could not be mass-produced without internal grinders and precision boring machines, and the new Bond Street plant went onto a total war footing. 3 shifts. Around the clock, 7 days a week, the building never went dark and never went quiet. By the family's own account, the workforce swelled to 3,000 people, and with so many of the shop's men drafted into combat in Europe and the Pacific, a huge share of the new hires were women, many of whom had never stood in front of a machine tool in their lives. They were trained in weeks and asked to hold aircraft tolerances anyway, fully aware of what a bad bore in a fighter engine could mean for the 22-year-old flying it somewhere over the Pacific. Imagine learning a trade at night, in a building that never stops shaking, where the acceptable error is a fraction of the width of a human hair, and where the cost of failure is somebody's son. They held the line, and the government noticed. The Army-Navy E Award was the nation's honor for excellence in war production, and it was genuinely hard to earn. Out of more than 85,000 American companies engaged in war work, only 4,283 facilities ever received the E, roughly 5 in every 100. Heald earned one by the families telling the first machine shop in all of New England to do so. And as the war ground on, the plant sustained its standards long enough to add stars to the E pennant flying over the factory, the mark reserved for continued excellence rather than a single good year. When the flag went up over New Bond Street, it meant 3,000 exhausted people, machinists and inspectors and women who 2 years earlier had never touched a micrometer, had been told, officially, that their precision was helping win the war. The engines that powered the Allied air fleets came out of factories built around Heald machines, and every bearing race and cylinder bore those factories produced traced back, one way or another, to a grinder or a bore-matic conceived in Worcester. The workers wore small E-pins on their coats around town. In an industrial city like Worcester, that pin meant something. So by 1945, this one-family company had helped win 2 world wars. You would assume that's the most dramatic government work this factory ever did. It is not even close. Most people never heard about this part. By the spring of 1960, Heald had taken on a contract unlike anything in its 130-year history. The customer was the National Lead Company of Ohio, the contractor operating a heavily classified uranium processing plant at Fernald, Ohio, on behalf of the Atomic Energy Commission. Fernald was a feed materials plant, one of the beating hearts of America's nuclear weapons production chain, the place where raw uranium was turned into metal for the weapons complex. The order, signed in June of 1959, was for a specialized multi-bore drilling machine that could drill 4 uranium slugs at a time. On paper, it was just another precision machine for another demanding customer. This contract seemed small at the time. It wasn't. Because before the machine could ship to a nuclear facility, it had to pass an acceptance test, the same ritual Heald had performed on thousands of machines since 1903. Run real parts, prove real tolerances, sign off in front of the customer. That inspection culture, the family religion of following every part through every operation, was the exact reason the government trusted this shop with the work in the first place. And here is the bitter irony baked into that trust. You cannot prove a uranium drilling machine on steel. The test material had to be the real thing. On March 16, 1960, technicians took background air samples inside the Worcester plant to establish a baseline. Then, beginning May 17th and running through midday on Thursday, May 19, 1960, Heald machinists drilled live uranium metal on their own factory floor, in the middle of a Massachusetts industrial neighborhood. The contract allowed up to 100 solid uranium cylinders to be run through the machine, and no record survives of exactly how many were. The machine sat inside an enclosure with no ventilation of its own. At the end of each working period, the crew partially decontaminated the machine and vacuumed the floor around it, and when the test wrapped up, the uranium, along with the radioactive chips and residues the drilling produced, was packed up and shipped back to Ohio. The air monitoring results came back essentially at background levels. The machine went off to Fernald, and everyone at Heald went back to grinding bearing races and engine bores as if it were any other week. You'd think someone would have said something. Nobody did. The job was classified. The Cold War was at its absolute coldest, and the machinists on that floor had no reason to believe those 3 days were different from any other acceptance test in the company's history. Most of them likely never knew what metal they had been cutting. The paperwork went into federal filing cabinets, where it would sit undisturbed for 4 decades. While the government kept its secrets, a quieter war was being fought inside Heald itself. This one was a war over physics, and it pitted a single scientist against a shop floor full of men who had forgotten more about grinding than most engineers ever learn. Back in 1944, the company had funded a fellowship at the University of Cincinnati for a young engineer named Robert S. Hahn. He earned his doctorate that year and came to Worcester to run Heald's newly created research department, a concept that was itself slightly radical, a research department inside a machine tool company. Shortly after the war, Hahn became one of the first American members of CIRP, the International Academy for Production Engineering, an invitation-only body that capped full membership at roughly 15 people per country. So Heald now had a genuine scientist dropped into a building full of master mechanics, and the mechanics had a creed, handed down for generations. You fed the grinding wheel into the work at a fixed, unyielding rate, and you trusted the sheer mass and rigidity of the machine to make the part round. Hahn's research said the creed was wrong. His pioneering papers on grinding chatter, thermal damage, and wheelwork conformity showed that no machine is infinitely rigid, not even one carved from a ton of cast iron. When a wheel feeding at constant speed hits a hard spot in the metal or a section carrying extra stock, the grinding force spikes, the spindle deflects by some microscopic amount, and the bore comes out with random size variation, unwanted taper, and a compromised finish. To men who had spent their working lives trusting iron, the claim that their massive machines were quietly bending was close to a personal insult. A university man was telling veteran machinists that flex they could not see was ruining parts in ways they could not measure until it was too late. The pushback was institutional, and it was stubborn. This was a company where knowledge had passed hand to hand since 1826, where the founder's great-grandson still walked the floor, and now the answers were supposed to come from equations instead of calloused thumbs. Hahn spent years measuring deflections that his critics insisted did not exist. Hahn's answer was controlled force grinding, and it flipped a century of practice on its head. Instead of forcing the wheel forward at a set rate and letting the force fluctuate wildly, a CF machine applied a constant predetermined force to the wheel head and let the feed rate float. If the wheel met a hard spot, it simply slowed down, but the deflection of the spindle never changed, so the bore stayed dead straight from end to end. The random taper vanished, and so did the guesswork. Heald built the concept into an entire line of CF internal grinders, and Hahn kept inventing 23 patents during his Heald career, covering tuned dampers that strangled vibration in boring bars, advanced hydrostatic bearings, and more. By the early 70s, he had pushed further still, pairing one of his CF grinders with a computer from the parent company to create a machine that adapted its own grinding forces in real time, up and running in Heald's product development department by 1973. The old-school mechanics had called him crazy. The industry eventually called his methods the future of precision grinding. The Borematic name, meanwhile, had become valuable enough that people tried to steal its shadow. In the mid-60s, a Texas firm called the American Manufacturing Company attempted to register the trademark Boremaster for cross-slide boring assemblies, accessories selling for around $5,500 apiece on lathes costing $50,000. Heald objected. The fight climbed all the way to the United States Court of Customs and Patent Appeals, and on November 9, 1967, the court ruled for Heald. Boremaster was refused registration as confusingly similar to Borematic. It sounds like a dry trademark squabble, but in an industry where a diluted brand could quietly bleed away defense contracts, Heald defended its name with the same intensity it defended its tolerances. Then the ground under the entire American machine tool industry began to shift, and the family era ran out of road. In 1974, amid a wave of consolidation sweeping the sector, Cincinnati Milacron, the giant born as the Cincinnati Milling Machine Company, acquired Heald and folded 148 years of independence into a corporate portfolio. The Worcester operation became the Heald Machine Division, and machines started leaving the plant with Cincinnati Heald on the nameplate. To be fair, Milacron bought Heald for exactly the right reason. It wanted the best internal grinding line in the world to sit alongside its own milling machines. The ambition was real. The timing was terrible. The broader decline that followed is a story you have heard in nearly every American industrial history. Cheaper standardized imports, brutal recessions, a domestic tool sector built around big custom machines and defense money, so we won't dwell on it. What matters here is the local ending. Through the 80s, the division shrank, and in 1992, after 166 years of continuous operation reaching all the way back to Stephen Heald's water-powered forge, the doors on New Bond Street closed for good, and the assets were sold off. For generations of Worcester families, a job at Heald had been a career you could build a whole life on, the kind of place where fathers got their sons and daughters hired in after them. That world evaporated with the stroke of a corporate pen. The building itself still stands in Greendale today, subdivided into leased industrial space, an ordinary address with an entirely non-ordinary past. And then, 8 years after the company died, those federal filing cabinets finally opened. In 2000, Congress passed the Energy Employees Occupational Illness Compensation Program Act, a law written to compensate workers whose health had been put at risk by America's nuclear weapons complex, including workers at private companies that had ever handled weapons material. When the Department of Labor assembled its list of covered sites, there, among the national laboratories and uranium mills and secret processing plants, sat the Heald Machine Company of Worcester, Massachusetts, officially designated an atomic weapons employer for a window of 5 days, May 16 through May 20, 1960. Former employees present during that uranium test became eligible for federal compensation of $150,000 plus medical coverage if they developed radiation-linked cancers, and government scientists later evaluated the old plant for lingering residual contamination. Those were the letters landing in Worcester mailboxes, the government finally answering a question the men inside that building had never known to ask. The machinists who ran that acceptance test punched out on a Thursday afternoon in 1960 with no idea they had just been written into the history of the atomic age. It took the United States government 40 years to tell them. And no, I'm not making that up. Here is the strange, almost defiant epilogue, though. The company is gone. The machines flatly refuse to be. Walk into precision grinding departments across the American aerospace and bearing industries today, and you will still find Heald iron running daily production, some of it 70 or 80 years old. Controlled force grinders still hold size in plants like Timken's, some retrofitted with modern touchscreen controls bolted onto Hahn's original hydraulics. Entire small businesses, several staffed by former Heald employees, exist purely to rebuild and retrofit vintage Heald 273A grinders and Barre, fitting them with modern servo drives for sub-micron aerospace work. And the redheads, those bright red spindles born in the 30s, remain such a fixture that specialist shops still rebuild them to factory specification, restoring bearings, balance, and micron-level runout for another few decades of service. One rebuilder reported a Heald Barre that had run production every working day for more than 35 years straight. James N. Heald's obsession with making each machine a little better than the last turned out to be a quiet form of immortality. The people at the center of the story took longer, fuller roads to their endings. Robert Hahn retired from Heald in 1980 and immediately founded Hahn Engineering in Northborough to keep developing force-adaptive controls, because apparently his idea of retirement was starting a company. In 1984, he was elected to the National Academy of Engineering. In 1996, the American Society for Precision Engineering handed him its Lifetime Achievement Award. In 2000, at 83 years old, he moved his research operation into the laboratories at Worcester Polytechnic Institute and became an adjunct professor advising graduate students. And when WPI launched its Center for Advanced Abrasive Processes in November 2006, tying the region's abrasives tradition back through Norton and Heald into the 21st century, Hahn's own control force machine was sitting in those labs, still doing active research. In 2017, the town of Oakham, Massachusetts, presented him with the Boston Post cane as its oldest living citizen. He died on January 5, 2021, 104 years old, having outlived the company by 29 years. The last Heald of the factory era was James N. Heald II. Jim was born in 1927, educated at Yale and then Harvard Business School, and put in 35 years at the family company, rising to vice president of the grinding division before retiring in 1986. He spent his second act giving it all back, more than 30 years on WP1's board of trustees, deep support for Worcester's museums and historical institutions, while his sister Nina Heald Weber built a philanthropic legacy of her own, donating thousands of historic postcards and artifacts to collections stretching from Massachusetts to Fort Lewis College in Colorado. In 1998, their grandfather James N. Heald was inducted into the Machine Tool Hall of Fame at the American Precision Museum in Vermont, enshrined alongside Eli Whitney. Jim died on August 5, 2024, at 96, and with him went the last direct link between the Heald name and the shop floor. But the ending I keep coming back to is smaller than any of that. Years after the factory closed, in a restaurant in Barre, the same town where a blacksmith first lit his forge in 1826, two elderly men happened to walk in just minutes apart. One was Bob Hahn, the scientist who proved that iron bends. The other was Jim Heald, the heir who had spent his life making iron anyway. They had not seen each other in decades, and by the account of Hahn's own family, the reunion was two old men shouting each other's first names across the dining room like schoolboys. An empire built on tolerances of 1/10,000th of an inch, and what survived it in the end was that. If you want another story of a company that quietly built the modern world and then disappeared, there is one from the archive on your screen right now. I'll see you in the next one.